Alright, let's learn how to combine like terms. Now in this video, we're just going to talk about the basics of combining like terms. We're not going to get into multiplying and dividing and using the distributive property today. Our goal is just to be able to identify like terms and begin combining those using integer rules. Alright, so let's just give you a real-life example of why we combine like terms the way we do and why we use the rules we do. If you notice here, I've got a bunch of fruit, specifically some bananas and apples. Now, imagine someone asks you, what type of fruit do you have? Well, you wouldn't count your fruit and say, oh, I've got, 1, 2, 3, 4, 5, 6, 7, 8 fruits. You wouldn't say that. What you would probably do is you would combine the fruit together that you have and tell them exactly how much you have of each fruit. And what I'm going to do here is I'm just going to put my bananas together, put my apples together here, and I'm going to say, okay, I've got 3 bananas and I've got 5 apples. Okay, I just added my bananas together. I added my 3 bananas together, and I'm going to add my 5 apples together. So banana plus banana is 3 bananas. Another way to say that is 3 times a banana. And if I just want to use the b, the letter b or the variable b to represent bananas, another way I could write this is 3 times b, or simply 3b. This would represent my 3 bananas. Same thing with your apples. If you counted your apples, you would say 1 apple plus 2 apples, 3, 4. I've got 5 apples here. 5 apples. Alright, well, we just repeatedly added 5 apples together. Another way to say repeated addition is multiplication. So I've got 5 times an apple. Or, if I wanted to use the letter or variable a to represent apples, I could say 5a. 5a would represent the number of apples I have. Now, we cannot combine the 3b and the 5a because they're not the same fruit. I couldn't say 3 plus 5 is 8, and I've got 3 apples because I don't, 8 apples because I don't have 8 apples. And I can't say I have 8 bananas because I don't have 8 bananas. And we wouldn't combine the 5 and the 3 together and 8 and combine the a and the b together and say AB, because this would stand for 8 apple bananas, and I definitely don't have apple bananas. I would just keep them separate and say I've got 3 bananas and I've got 5 apples. Alright, so this will make a little bit more sense once we get into our like terms. So, real quick definition, a like terms are terms whose variables and their exponents are the same. Remember, variables are usually represented as letters in algebra and math, and they're just letters who stand for a number. And exponents are those little numbers in the corner of our, say we have a 5 here, those little numbers in the top right corner of a number that tell how many times we multiply this number times itself. In this case, 5 with an exponent of 2 would mean 5 times 5. Okay? So, in order to be like term, 2 things have to be true. They have to have the same variable, or no variable at all would be acceptable, and they must have the same exponent or no exponent at all. Alright, our first expression here, I've got 4x plus 3y plus 5x. Alright, so the first thing we need to do is look at the variables here. I've got a variable of x, I've got a variable of y, and I've got another variable of x. Now, remember, the first thing we have to do to determine if they're like terms is make sure the variables are the same. In this case, the 2 variables that are the same are the x's. Once you know that the variables are the same, make sure they have the same exponent or no exponent at all. In this case, there's no exponent on any of these variables, actually, so we are good to go. It is okay if there is no exponent. That is the same thing as them being the same. Once you determine that 4x and 5x are like terms, what we're going to do now is for just a few minutes, just a second, we're just going to ignore those variables. They'll come back into play in a second. And we're going to use the integer rules for the 4 and the 5, which we call the coefficients. Since these have the same signs, we're going to add them. 4 plus 5 is 9. And we're just going to now tack on that x down here. 4x and 5x is 9x. And don't forget about your 3y. It is not a like term with 9x, so we cannot combine those. So I'm just going to bring him down here and put a 3y right there. So we just simplified that expression. Now, I did not tell you the value of x and y, so there's nothing else we can do here. If I don't tell you, you don't know the value of any of your variables, and you have an expression that's not an equation, really the only thing you can do is see if you can use the distributive property or combine like terms to simplify that expression, make it as small or as easy as possible. Alright, the second example, I've added a negative number here, and I just did that so we could practice using our integer rules. Alright, the first thing we do, look at our variables, y, x. None of them have any exponents, so the terms that are alike are the terms that have the same variable. Negative 3y, positive 2y are like terms. Now let's ignore those y's for a second and use our integer rules. Negative 3 and positive 2, they are definitely different signs, so we subtract 3 minus 2 is 1. We're going to keep the sign of the bigger number, which is 3, and it is negative, so negative 1, we're going to tack on that y there at the bottom. Don't forget about your lonely positive 2x over here. We're going to bring him down also. Now one point I want to make is that this y has a coefficient of 1 or negative 1. Now usually when we're using variables and they have a coefficient of 1, we're usually not going to write that 1. We're just going to take away the 1 and write it as negative y plus 2x. That's because 1 as a coefficient simply means multiplying that variable times 1, and we all know that multiplying something times 1 does not change that number. For example, if you have 1 positive 1y, that's the same thing as just y. So it is perfectly acceptable to use it or not to use it. All right? Just don't forget if it is a negative 1 to keep the negative with the variable. Alright. Throw in a few exponents here. Negative 4x squared minus 3x minus 2x squared. Alright, same deal here except that we have some exponents. Our variables are x, x, x. Okay, so we've got all x's here. However, we do have some different exponents. If you notice, two of the variables have an exponent of 2, and one of the variables does not have an exponent at all. Now, if you remember the definition of a like term, these terms must have the same variable, which they all do, but they also must have the same exponent. And the only two terms that fit this description that have the same variable and the same exponent are negative 4x squared and negative 2x squared. They have the same x and the same 2 as an exponent. So now, let's ignore the x to the second power just for a second and use our integer rules. Our two coefficients are negative 2 and negative 2. We know that if they have the same signs, we're going to add, negative 2 and negative 4. We have the same sign, we're going to add. 2 and 4 is 6. Keep the sign of the bigger number. The 4 is bigger, it's negative. Add on your negative there, and then we're going to tack on the x to the second power. Don't forget about your lonely little minus 3x up here. All right. Now, if you wanted to switch these around, if you wanted to write your negative 3x first, you can do that. Just don't forget about your sign that goes with it. That negative goes with the negative with the 3x. Minus, this also has a negative sign with it, minus 6x squared. And that is how we combine like terms. Now, I do want to add a quick little example here that I didn't mention that I want to just talk about for a second. If you have a term that is just a number, just like 7, I'm just going to throw one out there. 7 minus 6x minus 3. Okay, now we said that like terms must have the same variable. They can also have no variable at all, and we already know this. We've been doing this, but don't overthink this. The three terms here are 7, negative 6x, and negative 3. Well, obviously, negative 6x is the only term with a variable, and none of the other terms have variables. So we know negative 6x has no like terms. So I'm just going to bring it down here, negative 6x. But look at the 7 and the negative 3. Neither one of those have exponents, variables, but we know they're alike because they don't have any variables. We've been adding integers like negatives 3 and 7 for years now. We can still combine those. 7 and negative 3 are different signs, so we subtract and get 4. All right, keep the sign of the bigger number, so it is positive 4. So this term can be simplified as negative 6x plus 4 or 4 minus 6x. And that is how we combine like terms.